Hello friends, another important topic is this: how to check given language is regular or not. Regular or not. For this, if language is finite, then definitely the language is regular. If language is not finite, or if language is infinite, then how will check the language is regular or not? For this, we have one tool that is known as pumping lemma. Pumping lemma is a negativity test. It says that language is not regular, clear. But in exam we didn't use pumping lemma. We use direct method. How to check, we will see how to check the given language is regular or not. But first we will see pumping lemma for sake of completion of the course. Pumping lemma for regular languages. What is the statement for pumping lemma? If L be an infinite regular language and there exists W and W belongs to L. W is a string, belongs to L, such that length of the string is greater than or equal to n for some positive integer n, then W can be decomposed into three strings W equal to XYZ. W can be decomposed into XYZ such that first point, Y does not belongs to epsilon. Second, mod of XY is less than equal to n. Third point, for every k greater than equal to 0, for every k greater than 0, the string xy की power k z is also in L. Please see the statement for pumping lemma. If L be an infinite regular language and string W belongs to L, suppose there is any string belongs to language such that length of the string greater than equal to n for some positive integer n, then W can be divided into three parts, X, Y, Z. Y cannot be epsilon, mod of XY, length of the XY is less than equal to N. Then for every K greater than 0, if I pump Y again and again, then this string is also belongs to the L. If this, yes or no? For every K greater than 0, the string X Y ki power K Z is also in L. Is it clear? Note, this is pumping lemma is a negativity test. Pumping lemma says language is not regular. Note, first, every regular language satisfy the pumping lemma property. Every regular language satisfy the pumping lemma properties. Every regular language satisfy the pumping lemma properties. Clear? Second point, if a language L does not satisfy the pumping lemma property, if a language L does not satisfy the pumping lemma property, then L is non-regular. Clear? Next, if a language, please read carefully, if a language L satisfy the pumping lemma property, then L need not to be regular. Then L need not to be regular. Clear? Next, pumping lemma is used to prove that language is not regular, some language are not regular. are not regular. Clear? These are the notes for the pumping lemma. It is a negativity test. It is a negativity test. Pumping lemma is check the language is not regular. Clear? Now, see one example. Check whether the given language is regular or not. Check whether the given language is regular or not. Language is this: a की power n, b की power n such that n greater than equal to 1. Now take any string w, a, b, b. N, suppose n is 8. The mod of w greater than equal to 8, divide into two parts. This one is 3 parts. This one is x, this one is y, this one is z. Okay. If I pump by x, y square k equal to 2, also belong to the language or not? What is x, y? A. This is not belongs to the L. That's why given language is not regular. Not regular. Clear? This is the pumping lemma. This is pumping lemma. Check once. Read these notes carefully. But in exam, we don't follow this method. In exam, how to check given language is regular or not? First, see, please listen carefully. If the language is finite, then definitely is regular. If language is infinite, then there is any common pattern. If there is any common pattern, then this language is definitely regular, because we can make a loop in finite automata. Clear? We'll check given languages are regular or not. Check whether the given languages given languages are regular or not. Okay. See, first language, a की power n such that n greater than equal to 1. Second, a की power n, b की power m such that n greater than equal to 1. Third, a की power n, b की power n such that n greater than equal to 1. Now check these are regular or not. See, first, this is the infinite language. This is the infinite language. But there is a common pattern. it increase A, AA, triple A, and so on. So we make the loop. We make the loop. A, enter into the final and loop. So we find the common pattern. So we do the loop on the state. Clear? That's why this one is regular language. This one is regular language. Regular language. Clear? Now check this. This is the regular or not? Please check. Yes, check this one. There is no comparison. There is no comparison. Infinite language. A, any number of A's. After that, B, any number of B's. Any number of B's. This is the finite automata for this language. That's why this is also regular language. Clear? Now, what is is it regular or not? Now check. If I take this, there is a comparison. Please see. If the language is infinite and there involve a comparison, then we can say this is not regular. Please listen. If a language is infinite and there is involve a comparison, then we can say this is not regular. This is not regular. Why? If I make this diagram, then it is also except this one, A3B square. But this is not in this language. Clear? So there is a comparison. Please see. Number of A's equal to number of B's. Number of A's equal to number of B's. That's why this language is not regular. Not regular. Clear? Clear? Yes? Next one. Check the given language is regular or not. W की power r such that W belongs to any number of A's and B's including epsilon. W K greater than equal to 1. Please check these are regular or not. If language is regular, then we can also write the regular expression for that language. Have you done this? Okay, check. W is any string and WR is the reverse, and this is the infinite language. There is a comparison AB, BA, but finite automata does not have memory. It cannot remember the states. That's why no comparison is not possible. That's why this one is non-regular, not regular, not regular. Same here. When W is finished, again W is started. And it is infinite language. It is infinite language. It is infinite language. Suppose string is A, B, A, B, A. Then again start A, B, A, B, A, B. So this is also non-regular. Non-regular. This one is regular. Please check. There is no comparison. There is no comparison. We can make a DFA or regular expression. What is the regular expression for this? This is the regular expression. Or this is the finite automata for this. This is the finite automata for this. Clear? Next question. A की power I, B की power 2j such that I, j greater than equal to 1. A की power I, B की power 4j, I, j greater than equal to 1. Next, A की power n, n is even. Next, A की power n, n is odd. Yes, do fast. Yes. Do fast. Yes. Okay, check. This is regular or not? See, there is no comparison between A and B. B is always multiple of 2's. B is always multiple of 2's. See, what is the finite automata this? A, B, B. This is the finite automata for this. This is the finite automata for this. B always multiple of 2. B always multiple of 2. A double B is accepted. A B B is accepted. A 4B is accepted. Clear? But A single B is not accepted. A triple B is not accepted. B always in power of 2. Sorry, power of 2 nahi, is multiple of 2. B always multiple of 2. It means the we can draw the finite automata for this language. It means given language is regular. Same this one. This is the finite automata for this. A B B B 3 B 4 5 6 7 8 4 5 6 1 2 3 4 5 6 5 6 7 8 is accepted, 9 reject, 10 reject, 11 reject, 12 is accepted. This one. It means this is also regular. A की power n is even. It means number of A's are even. Number of A's are even. यानी epsilon A 4 time A, 6 time A, 8 time A. So what is the DFA for this? Or this is final A. This can be anything. Sorry, there is no B. This is the DFA for this. If n is odd, see, these are infinite language, but there is a common pattern. We make the loop in the finite automata. That's why these are the regular languages. Clear, my dear? N is odd. N is odd. See? N is odd. A accepted, 2A rejected, 3A accept, 4A reject, 5A accept. Clear? This is also regular. This one is also regular. Clear? Next. Next, A की power n is prime. N is prime. 12. A n square n greater than equal to 1. A 2 की power n A की power I, B की power j square I j check whether the given languages are regular or not. Yes, do fast. Take 1 minute for each question. Yes, have you done this? No. Okay, check. A की power n is prime. What is the prime number? 1, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, and so on. There are no common pattern. See, there is difference 2, 2, 2, but here 4, again 2, 4, 2, 4. So we cannot make the loop. That's why this language is non-regular. Non-regular. Clear? See, next question. There is no common pattern in between the prime numbers. If there is no common patterns, then how to make the loop? We cannot make the loop for this. That's why this is non-regular. Clear? Now check next question. A n square. A, suppose n is 1, then A. If n is 2, then A 4, 9, 25, 36, 49. There are no common pattern between A's. If there is no pattern between A's, we cannot make the loop. That's why this is also non-regular. Non-regular. Clear? Now check for next one. If I take n equal to 1, then it A square, n equal to 10, 2, A4, n equal to 3, 8, n equal to 4, 16, 5, 32, 6, 64, 7, 128. There is no common pattern between number of A's. That's why we cannot make the loop in finite automata. That's why this is also non-regular. Non-regular. Clear? Now check next one. This is also not regular. Why? Number of B's, there is no common pattern. J square. If I take J1, then b is 1. If I j2 take j2, then it 4, 3, 9, 4, 16. There is no common pattern for b's. We cannot make the loop. That's why this is non-regular. Non-regular. Same here, 2 की power n, b in power of 2s. First, if I take n equal to 1, then b square 2, b4, then 8, 16, 32, 64. There is no common pattern. So that's why this is also not regular. Non-regular. Clear? Yes, clear? Now check next languages. Yes. Next, 60. E की power I, b की power p, where I greater than equal to 1 and p is the prime number. Prime number. W such that number of A's in a W equal to, any type of question can be asked, equal to, greater than, less than, greater than equal to, less than equal to, any type of questions can be asked. Next, first do these two questions, after that we'll see next languages. Yes, this is not regular because there is no common pattern between the prime numbers. Non-regular. Non-regular. Please check this. Number of A's equal to number of B's in a string. There is also comparison. There is also a comparison and no common pattern, and there is no common pattern. That's why these all are non-regular. Non-regular. Clear? Please note it fast. Clear? Okay. See, next question. W such that number of A's in a W mod 3 less than equal to, greater than equal to, anything. Number of B's in a W mod 3 e की power n greater than equal to 10. W की power r, W belongs to any number of A's and B's including epsilon 21. a key power n, b key power n, c key power n such that n greater than equal to 1. 22. A key power n, b key power n plus n, c key power n greater than equal to 1. Please check these are regular or not. Try to do fast. Yes, have you done this? Take 1 or 2 minutes. After that, I will do these questions. Please check. Okay. See, this type of question we will do in DFA if number of A's in a W we can convert this question. Please listen. Number of A's divisible by 3 and number of B's divisible by 3. Number of A's divisible by 3 and number of B's divisible by 3. Please see. See the DFA for this type of question. Number of states is 9. Number of B's divisible by 3. We can make the DFA this is remainder 0 0. Number of A's, when we divide number of A's by 3, remainder 0. Number of B's, remainder 0. This one is 1 0. This one is 2 0. This one is 0 1 0 2. This one is 1A 1B 1 1. This is 2A and 1B. This one is 1A 2B. This one is 2A 2B. Now, suppose if I take this question, number of A's in a W mod 3 less than equal to number of, where the number of A's mod 3 less than equal to, this state is final, this state is final, this state is final, this one is final, this one is final, and this one is final. Clear? If I take this, then This one is final. 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 Clear? That's why this type of questions are regular languages. This is regular language. Regular. Now, a की power n such that n greater than equal to 10, it means number finite automata contain at least 10 A's. Contain at least 10 A's. Contain at least 10 A's. It means this is also regular. At least 10 A. The value of n is 10. Now, there is a infinite language and there is a comparison. First comparison is this. Again, this is also comparison. That's why this is non-regular. Non-regular. Now, there is also a comparison between this and this. This is not regular. Non-regular. We can write this as a की power n, b की power n, b की power m, c की power m. There is two comparison between ab and bc. That's why this is also non-regular. Clear? Clear?